Hello students, welcome to my class. In this video, I'm going to discuss examples on discrete mathematical structure, that is a DMS, for computer science engineering students. Subject code is BCS 405A. Okay. In this video, I'm going to cover examples from module 1. All these examples are from previous year question paper, that is 2024, June-July 2024. Two examples I am going to solve from first module, that is fundamentals of logic. Okay, let us start. First example is using the laws of logic, prove the following logical equivalence. Negation of P or negation of Q and F naught, that is a contradiction, or P and P is logically equivalent to P and negation of Q. So you need to prove LHS part is equivalent to RHS part. That's it. Okay. Using the laws of logic. Solution. Consider LHS part. So LHS part is this negation of this part. Negation of P or negation of Q and F naught or P and P. Okay. Now in the next step we are going to apply logical law for this F naught or P. Which law you are going to apply? Contradiction or P is what? This is identity law. So F naught or P is P itself. So in the next step, first part is as it is, negation of P or negation of Q, and in place of F naught or P is P by using identity law and P. This one as it is. Now, in the next step, P and P is what? It is P only because using idempotent law. So, negation of P or negation of Q and P is P using idempotent law. So, in the next step, we are going to use which law? Distributive law. So, what is that? Negation of P and P or negation of Q and P. This is distributive law. Now, in the next step, we are going to apply logic for law of logic for this part. Negation of P and P is contradiction. What is that? F naught. This is by using inverse law. So, by inverse law, negation of P and P is contradiction. That is F naught, or negation of Q and P as it is. So now again we have to use identity law for this. So already we have used that. Contradiction or some preposition in this part is always that preposition. So using identity law, we can write this whole preposition as negation of Q and P using identity law. So now negation of Q and P can be written as P and negation of Q, that is by commutative law, that is P and negation of Q. As we use in algebra, A equal to B, B equal to A, same thing. Just we have replaced the, changed the places. Okay, that is commutative law for logic. So, but what is this? This is our required RHS. Therefore, we can say the given preposition is logically equivalent to this RHS. Hence, wrote this question has been asked for 7 marks. Okay. Next one. Give direct proofs of the statements. First one, if K and L are odd, then K plus L is even. Second statement is if K and L are odd, then K into L is odd. Okay. Solution. Let us consider two integers K and L. And already here they have mentioned these two are odd. Okay. Therefore, we'll take both as odd numbers, odd integers. First one, if K is, let K be 2m plus 1 and L be 2n plus 1, where m and n are any integers. That set belongs to set of integers Z. As you know, 2m and 2n are multiples of 2. Those are even numbers. When you add 1 to that, that becomes odd. Okay, simply. That's why we have taken k as 2m plus 1, L as 2n plus 1. Now, consider k plus L. We need to prove k plus L is even. So, consider k plus L. So, k plus L is equal to what? K is 2m plus 1 and L is 2n plus 1. Okay, open the bracket. So what happens? K plus L is 2m plus 2n plus 2. And then in the next step, take 2 common. So you will get k plus L as 2 into m plus n plus 1. So it is nothing but multiple of 2. Okay. Multiple of 2 means it is divisible by 2. The number which is divisible by 2 is always even. Therefore, you can say k plus L is even. Okay. We have proved the first statement. Let us move to second statement. Consider k into L is equal to 2m plus 1 into 2n plus 1. Open the bracket. When you open the bracket, it becomes 4mn plus 2m plus 2n plus 1. Now, among these three terms, take 2 common. So, what happens? KL equal to 2 into 2mn plus m plus n plus 1. Again, what happened? It is first term is multiple of 2 plus 1. So, for multiple of 2, if we add plus 1, it becomes odd. That is, it is not divisible by 2. The number which is not divisible by 2 is odd. So, therefore, which is not divisible by 2, hence KL is odd. So, using the rule of universal generalization, we have proved both the statements are true. So this is also asked for 7 marks. I have chosen selected examples from that June-July 2024 question paper. If you want me to solve some more examples from this module, that is module 1, comment me in the comment box. We have particular examples that which you want to, so you want to know or which you want me to solve. Definitely I am going to solve those examples. In the next class, I am going to bring 2 examples from module 2. Okay, till then keep practicing. If you have any doubts, do comment in the comment box. Thank you. Take care.